This will be video 2 for section 5.2, and we'll pick things up on number 16. Again, I hope at some point we'll quickly recognize that this is going to be a semicircle. And we're looking at a radius of 4 this time, because again, you could just kind of plug some numbers in. What makes this function equal 0? Well, if I put 4 in. So 4 is a 0, negative 4 would be a 0, and at x equals 0, the answer is 4. So there's some reminders here to help us see that it is a semicircle. And this time we're only looking at from negative 4 to 0. So we're actually looking at just a quarter of a circle. So once again, we've got area equals pi r squared, but we want a fourth. And so area equals 1/4 of pi times 4 squared, which should equal 4 pi. So the integral in question is equal to 4 pi. Okay, number 17. We have the absolute value of x, so let's start with a sketch. And we know that that makes a V shape. And we're going to look from negative 2 to 1. Which gives us two little triangles that we need to find the area of. So let's do it separately. So area equals 1/2 of, we'll do the bigger one. Base is negative 2. Height is going to be the value at negative 2, which we should know is 2. And the second one is going to be 1/2 the base of 1 times a height of 1. So my total area equals, let's see, I put a negative 2 here. That's incorrect. The base length is just 2. So we've got 1/2 of 4, so that's 2 plus 1/2. So it looks like we should get 2.5. So we would say that the integral equals 2.5. Okay, looking at number 20, I recognize that this is a semicircle, but with a addition of 1 on the outside, that's going to affect the y value, so it's going to affect its location. So instead of having a circle centered at 0, 0, our circle at 0, 0 has actually been moved up 1. And so now we're really looking at this value here. Any value bigger than 1 becomes imaginary, so we don't get any answers. So at 1, for example, I get the square root of 0 plus 1. And so at 1 we have 1. So we end up creating this shape, which the easiest way to do it, again using geometry, would be realizing we have a semicircle sitting on top of a rectangle. So once again, let's do that separately. So if area equals 1/2 of pi r squared, and I'm going to add to that the area of the rectangle. Let's see, let's get some units on here, or some markings. The height is 1 because we moved up 1. So I have a rectangle that has a width of 2 and a height of 1. And my radius in question for this problem would be 1 for the semicircle. So that gives us 1 squared. So I have area equals, for the circle part, I have 1/2 of pi times 1, so 1/2 of pi. Add to that the area of the rectangle of 2. And there's really not much else I can do with that. And so that would be the answer to the question of what is the integral. Okay, 21. Some of us are going to get nervous with this question because it seems like it's maybe talking about trigonometry to some degree. But really, we need to pay attention to this value right here. This theta is simply telling us that on this graph that we keep making, my independent variable is now theta instead of x. And so we're looking from 0 to 2 pi. The question is, what's the function? And it's simply the function y equals theta, which is simply, since our independent variable is theta, if our independent variable is x, then it would instead say y equals x. So y equals theta is simply the exact same line of y equals x. Hopefully that makes some degree of sense. And so we have a triangle. The base length is 2 pi, just a number, and the height is what we get when we plug in 2 pi to the function y equals theta. So when I plug in 2 pi, I get 2 pi. So the area equals 1/2 base times height. Area equals 1/2 of 2 pi times 2 pi. So 4 times 1/2 is 2. So 4 1/2 is 2, and pi times pi is pi squared. So I appear to get an answer of 2 pi squared. Starting on 23, we move into a section where we're going to do the same thing. So we're going to graph y equals x. But this time, instead of giving us numbers like 0 to 5 or something like that, they're saying from 0 until b. And b, they tell us, is bigger than 0. So I'm just going to draw some random representation of where b is. So we'll say b is there, giving us a triangle. The base is b. The height is what we get when we plug in b to the function y equals x. So that would be b as well. So I simply get an answer of 1/2 of base times height, which would give me 1/2 of b squared. And so that is the answer to the question, what is the integral? On 26, same thing. We've got the function y equals 3t. So as I graph that, y-intercept of 0 and the slope of 3. Now that when we go from a to b, where they're telling me that a is bigger than 0, so that could be, we'll say here, and b is bigger than a, so let's say it's there. And if I look at the area under the function, again I have a trapezoid. And so now we're going to do exactly what we would do if these are numbers. Can't let the variables bother us. We have area equals 1/2 the height times base 1 plus base 2. The height of the function is the distance between, the height of the trapezoid, the distance between the two bases. So again, what's the distance from a to b? You would do the same math as if this was like a 2 and this was a 7. You would say the distance is 5 because 7 minus 2, or b minus a. And so my answer is 1/2 of the height, which is just the distance from those, b minus a, times base 1, that's going to be the height right here. If I'm evaluating the function at a, I should find that that's 3a. And at b, I plug into the function and I get 3b. So I have 3a plus 3b. I could FOIL this out and distribute the half to get a slightly different answer, and that would be fine. It's not necessarily required. So continuing, I have the picture of y equals x again, from a, which is bigger than 0, to 2a, which would mean it's bigger than a. And so I have another trapezoid. So area equals height, or 1/2 the height, which is 2a minus a, times base 1, which is a, because I plug a into y equals x. So I plug in a and I get a, and I plug in 2a and I get 2a. So I have a plus 2a. This one can be easily simplified. 2a minus a is simply 1a, and a plus 2a is 3a. So So I get 3a times a is 3a squared. And half of 3a squared would be simply 3/2 a squared. And that would be the answer to the integral question. And number 28. Actually, I'm going to stop this video now and we'll finish the rest of them in the last video.